Assalamu alaikum, this is Laiba Masood, and the topic that I am discussing today is the threat of data poisoning attacks on generative AI. So, if we talk about a bit of an overview of data poisoning, it's the intentional contamination of training data. The data basically that we're giving to AI models to train, right? What we're doing, what is happening is that data is being contaminated intentionally, is being corrupted to affect the model's performance and the final decision making of the model, right? So when we talk about the AI models that are used in generative AI, we're talking about GANs and VAEs basically, and we're going to be discussing them in depth in the upcoming slides. So basically, the goal of this presentation is to assess the current state of data poisoning attacks and discuss the detection and mitigating techniques used and the defense strategies to enhance the resilience of generative models. So, if you talk about GANs, these are generative adversarial networks, which were introduced by Ian Goodfellow in 2014. Now, these consist of two neural networks which are known as generator and discriminator. What the generator does is it creates samples and discriminator evaluates them, and both of them are performing simultaneously. It has applications in image generation as well as text synthesis. About the variational autoencoders, these are like the standard autoencoders with a variation, but they were introduced by Kigma and Welling in 2013. They have basically this model has an encoder which compresses the data into this latent space representation, right? So the latent space representation is basically where the encoded data is residing, and this data is later reconstructed into the original input by the decoder, right? So this is like a short overview of the overall working of GANs as well as VAEs. VAEs have their application in compression and data generation. So, if you talk about the key studies that we discussed in our review, were the top three were vulnerabilities in GANs, which stated the weaknesses of GANs, and it proposed adversarial training. We're going to be discussing this further in the upcoming slides. The next study basically stated methods to detect and isolate the poison data in variation autoencoders. The third study explored robust training algorithms and verification techniques for adversarial example generation. If we talk about adversarial training, in adversarial training, what we're doing is we're enhancing the model robustness, right? What we're doing is we're not just training the model on normal data, we're training it on perturbed data as well, so that the overall performance when the model makes decisions, it does not really get affected by poison data a lot, because initially it was trained on some noisy data, right? So it improves the overall model's robustness. The second is regularization techniques. We know that regularization is used for preventing overfitting. Overfitting is when the model learns the entire data in the during the training phase, and it performs exceptionally well on that data, but when it's given new or unseen data samples, it like fails to uh, it fails to test them correctly, right? So what we're doing is we're preventing overfitting on the poison data that was in the training phase, so that if we get perturbed examples in the testing phase, we're able to perform well, right? The model is able to perform well. The third is anomaly detection. In anomaly detection, what you do is you identify malicious data samples, you may remove them, you may isolate them. The fourth is post training verification, like you're providing feedback to the model, you're making sure that the generated outputs or whatever decision it made, it is reliable, it is correct. We talked about these real world examples before as well. That was deepfake image generation, synthetic voice generation, and text generation for fake reviews. Now, what are some problems that are make it difficult to detect the data poisoning attacks, right? So first is the data complexity, because data is very diverse. It is coming from a lot of various resources, and it is very high dimensional data, like it has a lot of features. So this is one of the problems. The next is adversarial transferability. What's happening in adversarial transferability is you have some adversarial examples that were specially crafted for one source model, right? And those examples can be used to fool or deceive another model, the target model. And basically these examples were not initially crafted for that target model, they were used for another model. Now it could it is this is known as like transfer learning vulnerabilities, right? So what's happening here is, even though the example was crafted for another model, it can easily be applicable on another machine learning model, even if the two models have the entire different architecture. Even if the two models are not similar in any way, it could be that there were two neural networks, two different kinds of neural networks, and the adversary examples could have been transferred from one to another. But it also could have been the case that one was a neural network and another was like a decision tree, right? So it's pretty easy to transfer. Now the attacker who is giving these adversarial examples does not need to know the structure of the target model. He does not need to know the vulnerabilities of the target model. He can just use the adversarial example from one model and transfer it to the other, and it could easily target, right, the other model. The third is evaluation overhead, which is the computational resources that are required for robustness assessment. And the last is scalability, which is large scale implementation. So, we presented a comparative analysis of the two defense mechanisms, adversarial training and regularization techniques. You can go through it. So, I'll just discuss where the two of them are different, right? So, training enhances resistance and it's quite computationally intensive compared to regularization techniques. And if you talk about adversarial tick training, it needs a lot of diverse examples to train on, but the same is not true for the other one. So basically it states that if it's taking a lot of diverse examples, right, it's quite complex, right? But at the same time it would help you detect sophisticated attacks. It would be like effective against them. In adversarial training, basically what you're doing is you're identifying the anomalous data, and after identifying you can easily isolate it, and it helps you detect false positives, and it has this predefined criteria. On the other hand, regularization techniques make sure that your model integrity is validated. It helps to detect post training behaviors. It has computational overhead, and it delays deployment. So, that was a brief comparative analysis of the two defense strategies. The next are the implementation tools that were used for mitigating data poisoning attacks. The first is TensorFlow privacy. This reduces the risk of data poisoning by ensuring data confidentiality. It is used in sensitive data applications like healthcare and finance. The second is ART, which is IBM Adversarial Robustness Toolbox. This provides a robustness against a wide range of attacks. It is basically used for R&D in secure AI applications. Now, some recommendations for mitigating data poisoning attack. What we can do is develop these robust data validation protocols that can identify and filter out suspicious or anomalous data entries right before they're entering the training pipeline. This helps to validate the data in the model integrity, and does not like compromise the overall data quality and like reliability of the decisions that the model is making, because the anomalous data is being filtered out right before the training phase, right? So the second is adopting privacy differential privacy techniques. What we're doing is we're adding noise to the data and making it difficult for adversaries to extract or manipulate sensitive information. Okay, so this is the conclusion. To conclude, we can say that data poisoning attacks are a significant risk to the integrity of generative AI models, and the models that we discussed, the GANs and VAVEs, are quite vulnerable during the training phase when they heavily rely on the quality of the input data that we're giving them. And what happens is it can be widespread because of the transfer learning that we discussed. And what it can impact is it can cause compromised decision making, biased outcomes, and reduced trust in AI technologies. Now, it's really important to mitigate these data poisoning attacks by using various techniques. Using robust data validation, differential privacy, and regular updates are also crucial to protect AI models from poisoning. We can use multi-layered defense mechanism, including adversarial training and anomaly detection, to enhance the model resilience. So this was it, and all the data that I presented in these slides and my literature review are cited in these references. Let's just talk about the future work first. And so in future work, basically the focus is on AI explainability. The models are we need to make sure that we understand how the models make decisions, which can help us identify the effect of uh, poison data, right? We can like lessen them, right? So it helps, this makes sure that there's this transparency and accountability in the decision making process of AI. The second is enhancing the AI model robustness. We have discussed this previously as well. So, this is also a research focus currently to ensure that the overall robustness is increased, and it ensures the reliability and security of AI systems across various applications. So, as I said earlier, these are some of the references that have been cited in these. Presentation slides as well as the literature review that I worked on. And this is the end of our presentation. And if you have any further questions, please feel free to reach out to me. And that is it from my side. Thank you very much. Allah Hafiz.